Let's see if it is actually, yeah, right. This is.
Okay, now we're going to go into subnets. Subnet is what most of you know or refer to as a network. A network is simply a collection of IPs that are very similar in a way. So similar to the network that we have here in the office, we all have IPs that look very similar. They all start with 192.168.11. something. So the first part of it is actually your subnet, or sometimes referred to as the network. These subnets, as I said, is basically a group of IP addresses. Now, these ranges, you can actually have different sizes or different number of items in front of it to specify the group. So you can have a group that's very, very big, where the only thing that we have in common is the first number of the IP address. The first one would, let's say, be 10, and the rest we all have different numbers, where yours can be 10.7.0.1 and his can be 10.15.18.2, which can be one subnet, which means they're on the same network. It's basically the same group of IP addresses. Or you can define a very smaller group, where you can say that only the last digit differs, which is a very small group of IP addresses. If you look at they call it the network mask. The mask specifies the size of the group, and it specifies how many of these numbers you'll use. There's three main ones that's used, and this is also where you can configure in Windows or in Linux, which we refer to as your network mask. Basically tells your operating system what size of network are you on. So there's these three sizes available, and usually you specify them with 255.255.255.0. Most of you will configure your pieces like that. Then if you're in a bit of a bigger company that might have a bigger network, it'll be 255.255.0.0. And if you have a very big network, it'll be 255.0.0.0. And I've written the numbers down here as well, which is the amount of IP addresses that that network can contain possibly. The number in brackets here is obviously the amount of IP addresses. So the top one would be 253. And we can also say that it's a 24-bit network mask. It does work in reverse. The bigger the number, the smaller the amount of addresses. So 24-bit will mean that one, 16-bit will mean that one, and 8-bit will mean that one. And you can see the 8-bit one can carry up to a little bit more than 16 million addresses. So that's a massive network. Or if you can call it a group. It's a group with a lot of IP addresses. These IP addresses are referred to obviously as on-linked or direct. That means there's no routing involved. If it's in the same subnet and you want to connect to a certain IP or want to send data to a certain IP, it goes direct. It doesn't go through any gateways, there's no routing information, it goes directly to that IP. I'm not talking about routers and physical cables, because there is still some management involved, but we're not going to touch on that level now. This is more related to software development. And on most software development projects, that layer is not really, you're never going to actually interact with that layer. Only on very exceptional cases. Okay, is there any questions on this part? Just basically the group part and these network sizes. Are we okay?
Cool. Can you, let's say you start with 24-bit subnet. Can you upgrade to like to 16-bit? Depending, let's say some organization now broad. Can you actually directly upgrade, or it's kind of?
You can. It just depends on if there's a conflict or not. Because what can happen is the organization can have multiple subnets with gateways in between. I'll get to that when we get to routing. Where if you then take one and you grow it to the next level, then there might be IP addresses in the same network that's exactly the same as in another subnet. Then you're going to have issues. But you can do it. You just obviously also have to update. If your IP address settings on each computer in the network is manual, you're going to have to update each computer. So that might be a bit of a problem. Otherwise, if you're in DHCP, where the IPs are automatically assigned, you can just reconfigure the DHCP server so that it will give bigger subnets to all PCs when they log in. Okay, or when they retrieve the IP. That answer the question?
Yep.
Cool. Anyone else? Not yet. Okay, cool. So now there's two specific groups of subnets that we can have. It's called private subnets and public subnets. Now the whole idea of the internet is that we have all these IP addresses everywhere to identify a PC on the network. And every server on the internet obviously has a unique IP. But one of the problems with IP version 4 as well is we're running out of IPs. And you don't necessarily want to make every PC that's on the internet give it a completely unique ID. So, and for that reason, there was a couple of things invented to circumvent this issue and to also make the subnets more safe. And one of the things that was invented is obviously the split between these two subnets. So we've got private subnets and public subnets. Private subnets, there's these subnet ranges I've listed here are actually official private subnets. So if you set up a network at your house, you must set it up in these ranges. Your private network at home with all your PCs now, they interconnect. So either be 192.168. whatever, because it's a 16-bit mask, which is that one, or 10.0.0. well, 10. whatever, which is an 8-bit mask, so that's the biggest one, yeah. Or 172.160.0, but it's not exactly a 0, it's, I think it goes up to 32. So it's between 0 and 32 dot whatever. The last one obviously is not used often. I actually haven't seen it being used ever, but that is actually an official registered private network. You can actually set up your home network to use none of these, which means it's public. So any IP that falls outside these ranges is considered a public IP. And you can actually do it. You can set it up that way, it will work. The only problem is some websites won't work because it won't route that packet to the actual website. It will try and find it in the local network, so it will break. Okay. So that's why these are actually official subnets, so that there's no conflict between private IPs and public IPs. Obviously, there can be a network at your house and a network at your house, and both can use the same subnet. But because they're not connected directly to each other, they're connected via the internet, it's not a problem. And that's when NATing comes in. We'll get to that in another lesson. That'll explain why there's no conflict when you have the same subnets at each of your homes. Okay. There's one IP that's very specific. It's also a registered IP, we can call it that. Is the 127.0.0.1 IP. It's also referred to as localhost. It always refers to the current machine, or the current device, or the current PC, or the current tablet, or the current laptop. So if anybody makes a connection to that IP, basically what it means, it makes a connection to this machine, this computer. Does that make sense? So you can't actually say that that specific computer's got this IP. Technically, every computer has it. It's referred to as localhost. You can actually, in your, if you have a web server running on a PC, you can in your browser just type in localhost, the word localhost, and it'll actually go to your web server on your PC. Or you can type in 127.0.0.1. It will also go to the same one. Okay. Another thing is that these subnets, like we've got here in the office, we've got this subnet range, 192.168.0.0, but we don't have a 16-bit mask, we actually have a 24-bit mask. Which means you don't have to make your subnet that big, you can actually make it a lot smaller. Which means that you can have subnets inside a bigger subnet. So you can have, actually what we do actually have that, because our office here, as well as our server environment, as well as the other office, they all fall in this range, but each office still has its own subnet. So ours here would be 11.0, the other office will be 21.0, so this will be 0.0. So that means that if you route a packet to this network, you still need to do subrouting to the right network, to the right sub-sub network, if you want to call it that. I'll go a little bit deeper into that as soon as we get to the routing part. Then you'll see why we can actually do that, because that'll make the rules that you configure on a gateway a lot less. So yeah, this is a little bit of a sketch that I've drawn up here with a subnet. That's a big subnet, 10.0.0.0. So that's technically the 16 million one. But inside it, I've created 5 sub-subnets, which is 10.0.0.1, 10.0.0.2, 10.0.0.3, .5, and .6. But those are subnets. Oh, sorry, wait. It's not 10.0.0.1, it's 10.1.0.0. 10.2.0.0. The biggest subnet obviously is 8, but the smaller subnet then is 16-bit, which means they're actually a little bit smaller. So if a packet gets routed here, we just have to specify a route to this network, the big network. As soon as it reaches the big network, it can then be subrouted to the smaller network. But everything outside this network, just need to know where just need to route the packet to that network. It doesn't have to know what subnet is in that network. It just sends it to the bigger network, that's it. Once it reaches that network, gateways in that network will route it to subnetworks. But I'll get more into the specifics with that as soon as we get to routing. How these, especially the public subnets, well actually both, the public and the private subnets, they're usually in close proximity with each other. So if you look at the subnet we have here, the 192.168.11, all the PCs are in this office. So they are very close proximity. So most of the time, they are physically on the earth, they sort of group together. Then you get your public subnets, which is also grouped together. It's just in a little bit of a bigger area. And usually service providers have certain ranges. And countries will have different ranges. So the IETF, they would say South Africa has these IP ranges. Well, a whole list of ranges, a whole list of, not ranges, actually we should call it subnets. But they have a whole list of subnets that belongs to South Africa. A whole list of subnets belongs to America. A whole list of subnets belongs to the UK. And these are shared with all the servers in the world. So as soon as a packet needs to go to some network somewhere, it goes and looks at this list. And it says, okay, cool, it fits into this subnet. So it will route it to the right country. Once it gets to that country, there is more smaller defined subnets to know where this packet should go next. But if you look at that picture, these subnets are sort of in a certain area. So they do use a form of geographical location to route the packets or to define subnets. That's why you can get something like an IP locator. If you just go to Google and you say IP locator, and you can put an IP in there, it'll actually tell you where this IP is in the earth, because they have an idea of where the subnet is. It's not always 100% accurate, but it will give you a fairly good idea. Okay. Let me see what else. Yeah, you don't have to have a gateway in your subnet. So basically a gateway, or obviously get to it once you get here. A gateway is a way to break out of your subnet. So if you want to send data to an IP address that's not inside your subnet, you have to go through a gateway. But your subnet doesn't need a gateway. You can just leave it blank. I think if you can't leave it blank, you just type in 0.0.0.0 as your gateway. And then it means that there's no gateway. That just basically means that you can only access IP addresses in the same subnet. You can't actually access anything outside, which most probably means you won't have internet either. So if you have internet, if your internet on your computer works, that means you have a gateway configured. That's the only way you can break out into the internet. Okay, does it make sense? Any questions? Nothing? Everybody happy?
Cool.